Now we are going to put out the values uh, in the loops. Epsilon 1 minus I1 R1 is equals to epsilon 2 plus I2 R2. We have been provided that epsilon 1 is equals to 3 volts, so 3 R1 is equals to 1. That's why 3 minus of I1, epsilon 2 is equals to 2, I2 is I2, and R2 is equals to 1. So 3 minus I1 is equals to 2 plus I2. So from this equation we get to know that 3 minus 2 is equals to 1, and I1 is going to be on that side, so it is I1 plus I2, that is equals to 1. And for the second loop, similarly, 3 minus of I1 is equals to 1 plus I3, and that's why 3 minus I1 is equals to, now I3. From this equation we are putting out the values of I3. I3 is equals to I1 minus I2. So 3 minus I1 is equals to 1 plus I1 minus I2. I1 is going to be on this side and 1 is going to be on this side, so 2I1 minus I2, that is equals to 2. Now we are going to compare these two equations, that I1 plus I2 is equals to 1 and 2I1 minus I2 is equals to 2. So from this equation we get that 3I1 is equals to 3 and I1 is equals to 1 ampere. We are going to just put out the values of I1 in any of the equation. If here we are putting the I1 is equals to 1, I2 is going to be 0. And if we are considering this equation, that 3 minus I1 is equals to 1 plus I3, and we are putting out the values of I1, that is 1 ampere. So 3 minus 1 is equals to 1 plus I3, and that's why we can say that I3 is equals to 1 ampere. Now we want to evaluate the potential difference between point A and B, but actually potential difference between point A and D is equals to 0. So we can directly say that whatever the current is flowing from I1, same is going from the I3, and that is also going to be flown from the this resistor only. So we guys can say that potential difference between point A and B, that is equals to V, and that is equals to epsilon 1 minus I1 R1, and that's why we came to the equation that V is equals to epsilon 1 minus I1 R1, that is equals to 3 minus 1 equals to 2 volt.